Okay, so the section's navigation and position determination. The motivation here is, as a pilot, are you going to be a child of the magenta line, or are you going to maintain geographic situational awareness between your ears by imagining where you are and using all the tools that are available for you? So this module will walk through some of the things that we think about, some of the equipment that's available, and we have to recognize that the audience is split between people that are pilots and have used this and maybe some people that have not. I'm going to try to tilt this towards pilots, and hopefully if you're not familiar with some of this stuff, you can do reading and talk to pilots to catch up on it. It's all really about applications for this presentation rather than how to twiddle knobs. So hopefully this will work for everyone. So objectives. We're going to talk about sectionals big time in this presentation and all the various nav equipment that we have. We need to identify airports, and there are two flavors, controlled and uncontrolled airports. They either have a tower that's functioning or they don't, and those are available on sectionals, which we'll discuss later. Sectionals being a short term for a particular aviation chart available in the United States. We also will discuss special use airspace. There's about a handful of them. Why are they important? They're important because you don't want to have a midair with an airplane that you could have otherwise avoided. And by talking about special use airspace, I hope that it'll remind people that you can call people ahead of time to get coordination, or call up approach control or center and get flight following from them to guide you through these special use airspaces as appropriate. We're also going to talk about 4 different kinds of navigational equipment. ADF is on this list. It's pretty much unusable because of lack of transmitting towers that are dying, but it's the mother of all electronic air navigation. It's a good starting point to orient people. We'll also talk about VOR, which is a more precise form of radio direction finding. DME, which is distance measuring equipment. It simply gives you a range in nautical miles from your airplane to a transmitting location. And then GPS, which is making us all lazy and lulled to sleep. Further, we mentioned the sectional chart. The Squitter asks MOs to chart a route on a sectional. In the old days, you would take a pencil and a straight edge and draw it out and then make a nav log. All of that pretty much available electronically now with ForeFlight and other electronic flight bags. A little side note, all VFR Capt pilots get a free subscription to a very high capability form of ForeFlight. So that's another benefit for getting your Form 5 done. You end up getting about a $200 or $300 subscription every year. There are also paper sectionals that I always carry one. We take our sectional, and this will be an MP Squitter item. You're supposed to take a paper sectional and actually superimpose the Capt grid system on it, which is a series of contiguous 7.5 by 7.5 minute areas that are given a particular designation and then are subdivided. Most everyone should have been exposed to this, at least the mission pilot candidates, as a mission scanner, and mission observers hopefully will become familiar with it, even though you weren't required to have your scanner done. Most people, I think, have. So that is the next thing. Oh, I wanted to say one other thing. The last objectives on that slide talks about going to the National SAR plan, which is, it's interesting. The acronym is IMSAR. That has been revised recently, and the supplement that they're talking about is now called the area. You'll also see magenta airports, all the little circular symbols with what are runway orientations are uncontrolled airports. They're in magenta. The blue ones are airports that have continuously operating towers, or if they're not continuous, then the actual operating hours will be in the AFD, the flight supplement. Also on this chart are, in the lowest edge of it, there are 2 interesting symbols. One of them is a little blue rectangle that is truncated in the northwest corner. That is our first special use airspace. This is a restricted area. They all start with a letter R for restricted and followed by a number. This special use airspace may be for use by agencies. They're generally controlled by air traffic control, typically the center or approach or departure. All of the information for contacting the person that's controlling that restricted airspace are on the edge of the printed paper sectional. All of the special use airspace is listed alphabetically on that, starting with the alert areas, starting with A, and then following through for prohibited and restricted areas. If you have an electronic flight bag, like ForeFlight, you can just touch on this restricted area, and by following the prompts, you can get all the information of the restricted area, including the frequency to contact the controlling agency, times of operation, altitude, definition, etc. Just below the restricted area are a number of darker lines. There happen to be two military training routes that run through the lower part of this image. They are listed as IR or VR, which is an IFR military training route or a visual military training route. These are really important for us because we operate down at 1,000 feet AGL typically for our missions. The visual military routes will be operating somewhere between 100 feet above the ground and 500 feet above the ground. So we're definitely in a conflict situation with anybody flying a VR route. Anybody flying an IR route may be a little higher. Typically, those might be flown at 1,000 feet AGL or sometimes a little lower. But the important thing on those instrument routes is with a lot of single seat airplanes, there'll be a flight of two airplanes. There'll be a guy flying or a pilot flying with their hood up so they can't see what they're doing. A chase airplane will be flying next to them to look for VFR traffic. So you could have two airplanes flying at about 1,000 feet, paying attention to each other, and one guy not even being able to look at you. So knowing that there's an IR route that might be going through your search grid would be a really important thing. Likewise, you may want to try to contact ATC with flight following to make sure that you know if the route is hot or not, and if it is, make sure that you have some sort of following. There are a few other special use airspace designations that I couldn't find on here, but they're important. Just with a quick review, I mentioned the restricted areas. There's also something called a prohibitive area. The prohibited area or the restricted area will allow you with clearance to actually enter them. The prohibited area, the best example is the one that sits on top of the national capital, Washington, D.C., which is a big deal to if you violate that one. And we recently had one of those incidents due to poor communication between agencies. The other ones, strangely, do not require clearance to enter, with the exception of a temporary TFR's temporary flight restrictions, which do require clearance before you enter from ATC. The ones that don't require clearance to enter, although enter at your own risk and flight following is always a good idea, are MOAs or MOAs, military operating areas, which typically surround operational or training military bases. Examples include Lemoore here in the middle of California in the area of Fresno and Paso Robles. Also up north of Sacramento, Maxwell has some fairly extensive MOAs, and they're all listed on a sectional with typically magenta outlines. Other areas that don't require clearance to enter, besides the MOAs, are warning areas, which are generally offshore over water. We have tons of them up and down the west coast of California. Those typically will be military operating areas, and within those, there may or may not be two other areas, a controlled firing area and an alert area. Alert areas typically are simply telling you to be vigilant. Controlled firing areas are areas, again, strangely, you don't need to have a clearance to enter the area. it is on the controlling agency to cease firing if they identify an airplane that has wandered into their area. But, you know, I myself would not feel very comfortable flying into a controlled firing area unless I knew that it was cold by checking in with ATC that was controlling that area. That is a pretty good roundup of the special use airspaces. I hope that you see why it's important to be aware of them and how we can be in conflict, especially when we're flying missions. So it behooves us to check in with air traffic control to make sure that we don't have that conflict. Additional symbols are available here on this other slide. In this particular slide, there are some controlled airspaces that are laid out in magenta. There's a number of little keyhole areas surrounding airports that pilots will be aware of. Non-pilots may want to look into those. Typically, most controlled airspace is simply designed to protect instrument flight rules flights from VFR airplanes. So these typically won't apply to us. We typically do our missions VFR, and if we're transmitting IFR, then we'll be protected by these things. So now let's get into the actual boxes that help us to navigate. Again, I think about these as aids for situational awareness. Every one of that is installed in the airplane should be used. If it's in the airplane, then it should be linked up to some sort of an indicator. If it's not, then you should turn the indication off. I'm thinking about the G1000 avionics for the most part. Six-pack airplanes will have dedicated displays for individual electronic nav aids. So again, if you've got that turned on, then you should have it tuned and adjusted so that it's giving you real information rather than just a needle floating around to distract you or make you think that you know something that you really don't. Frankly, the ADF is pretty worthless. It's not installed in most of our airplanes. It might be in some six packs. The primary use of an ADF receiver is to listen to AM radio so that you're entertained. As far as its pointing ability, it will often, even when you're close to the station, give you a variation of plus or minus 10 degrees in the direction to the station. But this is a good place to start for non-pilots because the idea here is that there's a transmitting tower putting out a continuous signal. We have a direction finding box in our airplane. It will find out where the signal is coming from and give you a relative bearing to that transmitting station. So the needle essentially would be pointing, giving you a relative bearing. Sometimes you'll get a more fancy RMI situation where not only will the pointer give you a relative bearing, but it will be slave to a magnetic heading, so you'll actually get a magnetic heading out of it. I'm not going to go into the details on that, whether it's automatic or whether you have to manually adjust the magnetic reference grid, because again, we don't use ADF very often, but it's the same notion that we have basically with our Becker automatic direction finding equipment for ELT searches. The next related electronic nav unit is VOR. So it's a VHF ranging equipment. VOR is an improvement over the ADF because with the additional magic of phase comparison, it can tell you where you are absolutely with respect to the transmitting station. The phrase that's used for the indicator is the radial. So imagine that you've got a wheel that is superimposed over a transmitting antenna horizontally. The spokes of that wheel are the radials, and the radial that extends north from the transmitting antenna is going to be a radial 0 or 360 because it can get two different names. As you go clockwise, you can see that the radial that is at the 3 o'clock position of this wheel is 090, so that's the 090 degree radial. And That is how you would orient yourself to a VOR. If you have a G1000, you can slave your display, your CDI display to the VOR. It will give you centering by dialing in the direction that you want to fly towards the station. And it will also give you needles. So you have the D bar as well as the needle that will be underneath that D bar arrangement. And I find that I like to have both of them. So I have a way to compare the information and also to go from course to fine tracking. Why is a VOR useful if we're not flying IFR and doing approaches? Well, one of the things that we do as far as searching for people is we'll do things called the route search. Somebody may have been flying an IFR flight plan and they will be on a VOR airway. And so you'll tune in the VOR and set it up so that you can replicate their path on the route search. And so this is where you have a direct application of the VOR, not just for figuring out where you are, but also for helping to guide yourself during a route search. The VOR slide here shows you all the different ways of setting it up. I don't think it's useful to go into those details. The main thing is that you need to select the actual station. You need to validate that you are on that station. The old days, you'd listen to the Morse code in the G1000 aircraft. You can look at the PDF and it'll show you the actual call sign of that VOR station, and that will be equivalent authentication that you're on the proper station and it's not in maintenance mode or otherwise not working. This is another way to look at the VOR. This particular setup is sort of an RMI where you can see that the needle pointing between 3 o'clock and 9 o'clock is showing you that the station is relative to you because the heading of this HSI is north. You can see that the VOR station is to the west, 270, but the tail of the needle, which is to the right of the center, shows you what radial you're on, and so you're on the 090 radial. The picture to the right shows that where the airplane would be relative to the station, which is shown immediately to the left of the airplane drawing, and that gives you an idea about geographically what it would look like. And then to the left, this is what an RMI presentation of the VOR needle would look like to show you that you are to the east of the VOR station. You'd fly west to get to it directly, and you would be on the 090 radial. There are some really good simulators that if you're not familiar with playing with VOR, you can download and practice interpretation of where, if I get a particular display of information for the VOR, you play the game of, well, where am I relative to the VOR station? This would be valuable if you're flying a 6-pack because of the way the needle presentation is as shown in the lower right-hand corner of this particular slide. For the G1000, this really isn't that applicable because it's a more advanced HSI presentation of the information. So ultimately, all the things that we've mentioned so far, I'm going to ignore ADF, of course, unless you're listening to KGO. The VOR and a sectional are really important tools to help identify where you are. We'll get to GPS later. The important concept is that you cross-check between the two of them. Where does the VOR say that I am? And you interpret the VOR. Then you take a look at the sectional. Then you look out the window and apply pilotage. When you do your Form 91, this is a very precise skill that will be tested for you. You'll have to find the grid, the search grid by pilotage without use of radio navigation, electronic means. And so you'll essentially be doing this without having the VOR cross-check. So this is a skill that, if you are not up on your sectionals, I suggest you really study them again, memorize all the symbols, remember that you can see the legend for those symbols on the edge of the sectional. If you have ForeFlight, you can look up the legends of in the document section of ForeFlights for the sectional if you forget what something means. Lastly, I'll say that make sure that you realize it's called MEF, or minimum elevation figure, that is provided about every plus or minus every degree on sectionals. That'll tell you what the highest elevation in that particular block is. Very important safety information that's right there in plain sight on a sectional. DME, we mentioned DME is simply a way for the airplane to tell you how far you are from a particular transmitter in nautical miles. VOR is broadcasting in the kilohertz range, like 108 to like 118 kilohertz. TACAN and the DME equipment associated with it is operating in the megahertz range, and therefore it will be limited by a line of sight for which is typical for UHF. DME is in G1000 airplanes is not really radio received. In the G1000 airplanes, remember that it is simply synthesized from the GPS position and calculated. So when we talk about DME, one of the quiz questions may be this business about slant range. This picture shows you that the airplane is, let's say, a mile high, so it's at 5,000 feet. Let's say that it's 1 mile away from the transmitter there, and you can see that part of the ranging, it'll tell you that you're 1.4 miles from the transmitter, when actually on the ground you're horizontally only a mile away. With GPS, this slant range air is not present. It's simply a horizontal measurement from the location of the DME transmitter to the aircraft horizontal position. And also notice that when you get to 5 or 10 miles away from a DME transmitter, the slant range is really negligible anyway. At 1 mile away, you've got a 0.4 mile air. Once you get to 10 miles away, it's significantly less, since we're operating more like 1,000 feet, not even 5,000 feet high. And then here's another picture of that. This is a picture of the old 6-pack style of DME. And again, there isn't even a box like this in the G1000 aircraft. It's synthesized from the GPS position. Which brings us to what we're all really starting to become slaves to nowadays, the GPS. There are a number of important concepts about GPS. Won't get into any of the technical aspects of it, because let's just pretend that it's all by magic. There is a current system known as WAAS, W-A-A-S, which is Wide Area Augmentation System, which is the system improvement that gives GPS the accuracy that it now enjoys. It used to be more like plus or minus 100 meters. Now we're down to a handful of meters in air in 3 dimensions. For MOs and also pilots, recall for G1000 airplanes that you need to go to the aux page, and simply by looking at the GPS, what GPS satellites are being received, if they have a little W sign on them, you'll know that they are receiving WAAS. And if they're not receiving WAAS, then the rules for approaches that require WAAS do not apply. What does apply is something known as RAIM, which is Receiver Autonomous Integrity Monitoring, and there are rules that the pilots that are IFR qualified should know about that on what you need to do there. The really important point about GPS is that it gives you a lat long readout on the G1000 airplanes, and all of the airplanes in CAP that have been retrofitted with various Garmin receivers also will give you terrific information. But the terrific information requires for MOs that you realize what format you're reporting in. And by that I mean the CAP standard, which is degrees, minutes, decimal minutes, rather than degrees, minutes, and seconds format. So for MOs, please refresh your understanding of the difference in formats. Whenever you report positions, it should be done in DMM format, which is degrees, minutes, and decimal minutes. And also, when you're reporting your GPS positions, make sure that you're identifying what you're using by saying this many degrees, this many minutes, decimal minutes. and that way someone won't accidentally write down degrees, minutes, or seconds. If you do accidentally give it to them in degrees, minutes, and seconds, you should say so many degrees, so many minutes, and so many seconds, and at least they'll understand what you've given them. For GPS navigation relies on waypoints being entered, which makes it a real time hog for MOs. You can be buried in the cockpit punching in tedious numbers by twisting and turning knobs. You can end up accidentally putting in 1 or 2 wrong digits and you'll have a totally incorrect waypoint. So your method of inputting waypoints needs to be efficient. I would recommend that whenever you're thinking about a mission, you minimize the number of waypoints to the absolute minimum, and that that you make sure you don't skip the step of validating what you've entered by looking at the map in the case of G1000 in the MPD to see that it does make sense and that it does seem to agree with the sectional that's presented underneath it. For pilots, I would like to emphasize that in the data strip over the MPD, I find when you're doing your setup before a mission, make sure that you have the data strip that you want over the MPD. The data strip that I prefer has 4 different parameters. From left to right, they would be ground speed, cross-track air, estimated time en route, and then FOD, which is recommended by CAP. Why that particular data strip? Firstly, as we'll discuss later in search patterns, we fly our search patterns at 90 knots. That's 90 knots ground speed. If you've got a typical 10-degree wind like that we often have in California, then when you're flying in one direction, you'd be doing 80 knots of ground speed, even though you're indicating 90. And when you go the other direction, you'll be doing 100 knots. We want 90 knots of ground speed so that we get a more consistent search. And by looking at that ground speed and bringing it into your scan, then you'll be a much more precise pilot executing the search pattern that you've selected. Cross-track air. I find cross-track air to be an excellent tool. It's an excellent tool in the G1000, and it's even more valuable when you're flying one of the retrofitted GPS boxes. A cross-track air is something that can be displayed in a similar fashion on the smaller 400 and 600 version boxes, Garmin boxes. This can be applicable for parallel searches where you want to stay on a particular line that you're flying. It can be very valuable if you're flying a point-based search. You can put in one waypoint and automatically fly a point-based search using ground speed, cross-track air, and driving it using the heading mode of the autopilot. So much better to simply automatically put in a waypoint by pressing the enter button and then selecting that waypoint and then flying relative to that waypoint using the data strip information that I'm recommending, whether it be a G1000 on the MFD or if it's one of the aftermarket boxes that we've retrofitted some of our non-G1000 airplanes with. Position determination is a synthesis of all kinds of inputs into your imagination. I have talked to people that have begun their training with GPS. Somebody even wrote a book called Children of the Magenta Line, I believe. And I've talked about people that think in different ways about navigation. One orientation that is really important is in a G1000 airplane during your setup is to decide whether you're going to orient the map north up, which is my preference, or if you're going to orient the map track up. It's all about glancing over at the MPD or down at your sectional, and I do both because I've got it, the sectional out on ForeFlight as well as glancing at the MPD and seeing if they corroborating each other. If you're composing all this in your mind, I find it easier to fly north up on both of the displays. People argue the other way, and I can see where if you've trained yourself to go with a track up orientation of your charts, then that could work for you as well. But just make sure you've thought about it and chosen the one that works best for you and use that consistently. Again, cross-checking everything is the most important thing so that you don't accidentally get lost in the middle of flying something, so that you can react to new information and so that you won't be distracted. For those not familiar with the sectional aeronautical charts that are shown here, it gives you the scale. It says it's a 1 to 500,000 scale chart. You can see that the entire United States is composed of a number of these. You need 5 of these sectionals to cover every nook and cranny of California. You'll see you need the Las Vegas sectional to get part of the mountains near Tahoe. You'll need to use the Phoenix sectional to get part of California near Yuma. And then up north, you need to have the Oregon sectional in order to cover the northern part of California. So Columbus sectional, San Francisco, Los Angeles, Phoenix, and Las Vegas sectionals will be what you need. If you're flying with ForeFlight, well, you just need to remember your iPad, and all of that stuff will automatically be integrated together. Know where to find legends in ForeFlight or on the paper chart. Know how to decode the information block that is provided next to every airport that are depicted on the sectionals. This would apply to MOs as well as to mission pilots, because MO, you might need to cut through an area close to an airport, and all the frequencies are there, whether it's a towered or non-towered airport, but only if you're familiar with exactly where to find that data and quickly. If you're not in a G1000 airplane where you can look up using Nearest, it's really a valuable piece of knowledge to have. Reminder for those that didn't go through scanner training, the way a CAP gridded sectional works is each one of our CAP grids is actually a 15 by 15 minute grid. Those are further subdivided into 4 subgrids labeled as A, B, C, and D. And notice that it's not a clockwise numbering. Remember that it's in the northwest corner, it's A, going to the right. In the northeast corner, it's B. Then you skip over to the southwest corner, it's C, and then in the southeast corner, it's D. Each one of those would be a 7.5 by 7.5 minute grid. So in the perfect world, that's something about 7.5 nautical miles by 7.5 nautical miles. An example of a CAP grid would be the Oakland squadron is actually, let's see if I wrote it down here somewhere. It's like SFO 264 Alpha would be the CAP grid for the location of the Oakland airport. And so that would define this 7.5 by 7.5 minute grid. In our latitude of around 37 degrees, the shape of that CAP grid is actually not a nice rectangle because the lines of longitude are converging as they go north towards the North Pole. Actually, the width of the CAP grid has shrunk, so it's more like 6.4 nautical miles wide, and then it's 7.5 nautical miles measured north to south. That's important when you're thinking about planning search patterns, the length of lines that you might be flying. If you're flying north-south in a CAP grid around our area, it's going to be a 7.5 nautical mile line. If you're flying east-west, that's going to be more like a 6.5 nautical mile line, and that may be a significant factor. Use of electronic flight bags. We've already gotten the pitch that if you're a VFR pilot in CAP, you get ForeFlight. I used to use another electronic flight bag by Seattle Avionics that I was getting as a freebie as a CFI. I absolutely love ForeFlight. It's got CAP grids available on it. It also has the ability to display TFRs, which is very important for us during fire season in California, to have the TFR automatically shown to you on the equivalent of a sectional is really important if you're flying to the TFR to do Waldo photo missions. And it's very important so that you can know where the air tankers are flying if it happens to be a forest fire generated TFR, and be cognizant that the tanker is going to fly from that area to the CDF fire bases. So it's a safety of flight issue when you think about it, using that TFR location and knowing that you may be transiting that area. the guy says, when do they start naming runways with Roman numerals? Because he sees Roman numeral X on what he thought was the airport that he was going to land at. There's a guy in a backhoe waving at him, and the X obviously is superimposed on a runway that's been closed, and the X is there because you're not supposed to land on it. So a little pilot humor, I guess. The message in this is more than knowing your chart symbols. Underneath the X, there's a little indication that says NOTAMs, which is notices to airmen. This guy obviously didn't check his NOTAMs to know that the airport he wanted to fly to was not available. Using your electronic flight bag, all that stuff is available for you now, and before flight and even in flight, you can check information like that. So any questions?
Yeah, I have a comment I wanted to make about the GPS stuff that you talked about. For mission observers, there is an advanced task that's called operate the GPS. And the specifics of how to use the GPSs that are in our various aircraft are not covered in this course. So you're going to need to find some other way to learn how to operate the G1000 and the other ones that are in our aircraft. There's lots of good YouTube videos. There's lots of good training online. There's lots of good Capt sourced training that has gone on and has been recorded and is available. Many squadrons cover this during their meetings. There's lots of resources. Ask around. It's kind of funny that it's not actually part of this training.
One specific one, Jordan, is the G1000 class for Capt pilots. If you haven't done your Form 5 yet, or you're going to do your first Form 5, you need to take that G1000 class. There's a VFR version and an IFR version, and I think you have to renew it every, was it 4 years? Something like that.
Yeah, 3 years.
But you don't have to be a pilot to take the class, so there's some good learning there.